because the time is short, I will concentrate on the one thing about which I know something, which is the biology. Everything else I have to mention, but I will sort of fly over because of time, but also because of knowledge, which I don't have. And remember that we are talking as the origin of everything to the Bible, the book by excellence for the three monotheistic religions of the world and of the West, Middle East. And it is not, I'm not the first one, and it is not the first time that we discuss topics relating to the Bible from a medical, a scientific, a biological viewpoint. And Professor Robert Greenblatt, who was one of the founders of reproductive endocrinology, I had the honor and the pleasure as a young student to meet him, and he wrote a book about the search of the scriptures to see if he could find biomedical explanations for some of the things described in these old books. And again, I don't want to go over these things, but what I will try to do is to attempt a scientific analysis of the greatest of all the events described in the New Testament, which John in the Gospel called, "And the Word became flesh." I'm not the first one, and I'm sure I will not be the last one to debate and discuss these kind of issues. Edward Kessel, some 35 years ago, also worked on it and proposed a biological interpretation, saying that Jesus was not only conceived as a female, but remained chromosomically such throughout life. And then he added, through the natural process of sex reversal, Jesus became male, not instead of female, but as well as female. And I stop here because this is exactly what I will try to see, to look at with the knowledge of today. And you know that the scientific truth is an imaginary line that divides the error in two parts. One part we know it's wrong, and another one that we still believe it's right. But eventually many of these truths change, as you all know. So another biologist, Robert Berry, had a different thesis. Some form of distinctiveness like a virgin birth is theologically required if Jesus is to be divine as well as human. And there are a number of mechanisms through which this could occur. And he goes on and tries to describe them, but I'm talking about 25 years ago. But what is important is that if you investigate what I would call the biology of incarnation, by necessity you have to also deal with theology, about which I know but little. And the tradition of the virginal birth of the Messiah dates back to the prophet Isaiah in the 8th century before Christ. And he wrote, "Behold, the virgin shall conceive and bear a son, and shall call his name Emmanuel." And 8 centuries later, we have the description of this event by the evangelist Mark, and I will only read to you the 2 sentences in red. What the angel said, "Hail, full of grace, the Lord is with thee. Fear not, Mary, for thou hast found grace with God. Behold, you shall conceive in thy womb, and shall bring forth a son, and thou shalt call his name Jesus. Now, this is a description of theology, not of biology. But because it was a description of biology, you would have to say, but what has biology got to do with the gospel? Now, the issue is, in a way, very simple. If you believe in the Holy Spirit's intervention, then nothing is impossible to God, and it's easy to accept even such an event. If one doesn't, this story is simply absurd. So each one of you will take it in whichever way you wish, because you either belong to one group or you belong to the other. But a miracle per se does not imply bypassing a biological or physical law. So in theory, it is possible to analyze mechanisms that might be involved in the miraculous birth of Christ. So I will deal with the two involved here. Two, not one, because the first is human parthenogenesis, and the other one is what in science we call phenotypic sex reversal. And we will go through these two. Remember that in reproduction there are three systems. The one we all belong to, which is the XY system, and in this system it is the spermatozoon that determines the sex of the offspring. Then you have an XO/X0 system, and in this system the male is the heterogametic sex because it has only one X. And then there is a third system called the ZW system, and in this system the oocyte determines the sex of the offspring. So Mother Nature never makes things easy. It decided to develop three lines very different from one another, and in one the male plays one role, in another it plays a completely different one. Now obviously we as mammals belong to the first group. And okay. Now there are parthenogenic species in all the systems, all the three systems, but in the XXXY system, the parthenodes are invariably females. That's why I remember once some scientist who said, but to enter a discussion on the birth of Christ, you need two. He called at the time impossible situation. And so the natural parthenogenesis exists, and it's present in both the invertebrates and the vertebrates. But intriguingly, in the XXXY system, our system, offspring usually have a diploid chromosome set, since the haploid chromosome set of the oocyte, it's a parthenogenic development, is duplicated as an early event during the embryonic development. And so the offspring is diploid. Now, you have insects among which parthenogenesis is utilized to obtain workers. And in mammals, parthenogenic embryos fail to develop They exist, but they fail to develop beyond the embryo stage. But if we look at pathology, you know, pathology has many fascinating aspects beside the terrible thing that is, if not often, in a number of cases, deadly, but it's intriguing. And parthenogenesis is possible even among humans if you look at the pathology, because dermoid cysts, teratoma, both the malign and the benign, are of parthenogenetic origin. Obviously, they don't go anywhere. On the contrary, they only create trouble. Now, this is interesting. Some 85 years ago, the American anatomist Joseph Krafka described the early cleavage division on non-fertilized human eggs. And these would be developing even prior to ovulation. However, these observations are a far cry from the development to term of a parthenogenetic embryo or fetuses. Indeed, these phenomena that Krafka described stop at a very early stage, or if they continue, they develop into a dermoid cyst or a teratoma. So that is not something we can try to use in the hope of explaining parthenogenesis. It doesn't go anywhere. Now, cloning could be considered an artificial form of parthenogenesis. First of all, it's artificial, and you all know, and I won't spend time on the work of Sir Ian Wilmut with the famous Dolly sheep, and so I will go over this diagram explaining how it is done, and I will tell you why it is not really important for our discussion. What is important is that 25 years ago, many believed that human cloning was around the corner, even though in 1997, as it happened, at the time I was the director of the WHO program for reproduction, and so I was there in the World Health Assembly when it formally banned every human of any type human cloning experiment. The vote was unanimous with one vote contrary, and it was from Zimbabwe. And the guy at the time was a white minister who said, "This is not strong enough." It was a complete ban. I don't know what else he wanted, but the only one who was opposed was because it wasn't strong enough and not because he wanted it. So the international community closed but not only the international community, because also the creator of Dolly, Professor Ian Wilmut, decided, and the Telegraph said, shuns cloning. I don't want to go through all of this because it's tangent to what we are discussing. Now, irrespective of any ethical consideration, cloning really has got nothing to do with spontaneous parthenogenesis, and therefore it is not part of the discussion we are having today. Rather than in cloning, the future in terms of trying to find an explanation may lie in a complex alternative method of asexual reproduction in mammals, developed by the Japanese scientist Shinyo Yamanaka. His group utilized the so-called pluripotent stem cells, something you all know about, which are becoming extremely important in many fields of biology and medicine, and will really help us in many, many different ways in the future. So, using pluripotent stem cells artificially obtained from a reprogrammed adult cell, you know the system, you take an adult cell, the adult cell will have all the information that the primitive cells after fertilization have, but over the time lost most of it to concentrate, that particular cell concentrate its activity only on its specialty, skin cell, brain cell, and so on. And again, I'm not going through this, but he was able, he and his group, Yamanaka, to induce the growth of an embryo from adult fibroblast culture using the nucleus. And obviously he had a great idea because he was given the Nobel Prize in Medicine and Biology in 2012. And as I said, the field of stem cell research has been greatly developed over the last decade, and today many applications exist. However, although it is possible to induce parthenogenesis even in primates, and Mitalipov and collaborators some 20 years ago have artificially activated macaque oocytes with the technique of nuclear transfer. Okay, the bottom line is that all these experiments did not produce vital offspring. And the reason seems to be that in mammals, biparental reproduction is necessary due to epigenetic modifications occurring during gametogenesis. And so you need a full system in order to get where we all would like to go. But if one utilizes induced pluripotent stem cells, artificially derived from a reprogrammed adult somatic cell, vital offspring can be obtained in mice, which is a major step. And these animals have been proven to in turn reproduce successfully. So this is a viable system. However, it's very complex. It's called tetraploid complementation, and it requires the creation through sexual reproduction, mind you, of normal diploid embryos who are fused to produce a non-vital tetraploid embryo, which is necessary to furnish the base for the development of the new asexually obtained embryo. You know, the placenta, the amnios, etc. So, besides being very complicated, this method also has got absolutely nothing to do with the kind of parthenogenesis we fantasize about. And so, there is not even a remote chance that these fascinating techniques can be invoked for the spontaneous activation of an adult somatic cell. And even admitting that such a phenomenon might happen, there is, as of now, no possibility that these reprogrammed cells, pluripotent stem cells, can develop without the tetraploid substrate. Now, a Chinese group produced an unlimited number of oocytes for parthenogenic embryos, and they claim that they can use healthy offspring, and this reproductive biology branch is in full swing, and we will see. However, it seems highly unlikely that they will shed light on spontaneous human parthenogenesis, the only thing we are interested in this discussion. There are other options, and I don't want to go through because the time is what it is. But, for instance, this group, a commercial company in the United States, says very clearly that these are not fertilized and no viable embryo is created or destroyed. So although they have all these techniques, it's not for the purpose of having a parthenogenic birth. And they have been working. I searched for the most recent of their statements, and again they say no attempt has been made to create human embryos with this technique. Although there is plenty of work in the specific area that we are discussing today, there is basically no work that even remotely indicates that it could be done. Now, as I said at the beginning, when dealing with the birth of Christ, there is a second fundamental issue that makes it a double miracle. Because in the XY system, the one I showed earlier, the parthenogenic conception leads to the birth of a female infant, not of a male. And I have to go back to the Bible in order to make a discourse that has some sense. And Jeremiah said, "The Lord has created a new thing upon the earth, a woman shall compass a man." And the historian of the Jewish people, Heinrich Ewald, some 150 years ago, not yesterday, provided the following controversial interpretation of this text: "A woman shall change into a man." Now, contrary to everything I said up to now, this phenomenon is not only possible, but it exists in nature. So this part, we know, could have happened. But without the first part, we are nowhere anyway. And sorry, I made a mistake. Now, I don't have the time to go through how and what causes the male to become a male. But the sex-determining region in the Y chromosome is where the male sex differentiation begins, and the development of a male is brought about by the transient expression of the gene SRY located in this region of the Y chromosome. Now, without discussing all the complex things that happen, we focus on a phenomenon. In mice carrying the ODS mutation, natural mutation, sex reversal does occur in the absence of the SRY gene. And this is due to a mechanism which is called upregulation of SOX9 expression. So the ectopic expression of SOX9 gene in the gonad of an XX mice leads to a complete female-to-male sex reversal. But what is even more interesting is the fact that this phenomenon naturally exists among humans. The first It was first described by a French group back in 1964, so it's not a novelty. And human XX males exist, but they are sterile. And their chromosomes seem, I say seem because now you can analyze a chromosome in a way very different from what they could do in 1964. And about 1 every 20,000 males has a karyotype 46XX. These cases contain portion of the Y chromosome. This is what now, 30, 40 years later, was discovered. So they are complicated chromosomically. And there is a report, relatively recent, of a family where 3 adult males were in fact genetic females based on their karyotype and the negativity for the famous SRY gene. And the only feature was the existence of an approximately 178 kilobyte duplication of a segment of chromosome 17, not the Y chromosome, situated some 600 kilobytes upstream of the location of the SOX9 gene. These adults suffered from a 46XX testicular disorder, but general growth and health, all secondary sexual characteristics, the skeletal system behavior, and intelligence were normal. So this applies even to what we are discussing. I'm not saying that it ever occurred. I'm saying that we have a mechanism that explains the second part of this discussion. And in conclusion, on the one side, there seems to be no spontaneous biological mechanism that can explain the virginal birth of Christ. And I disagree with what Kessel said 30 years ago, that parthenogenesis may take place in humankind. No, it doesn't as far as we know today. And also the observation by Kafka cannot be considered a way for the development of a parthenogen. And there are statements that have been made over the previous century, and there is one very last issue. Is it possible that Christ, if he was the offspring of a parthenogenic birth, be an androgynous type? And Kessel, on the one hand, believed that Jesus was neither an hermaphrodite nor a pseudo-hermaphrodite. Someone else, a guy called Mollenkott, hold the opinion that in the Bible God is presented as androgynous. He says, because he is the creator and he creates men and women, and he says that he created them at his image. Now, we move away from biology, and so I'm not going to discuss this. It's certainly not my... The truth is, in my opinion, that there is no natural mechanism known through which the birth of Christ, parthenogenic birth of Christ, can be scientifically explained. And to finish, all I can say is that Christmas, therefore, remains a mystery that only faith can consider. And paraphrasing a character of one of the greatest Italian romance writer, Alessandro Manzoni, if you don't have faith, you can't give it to yourself. So you either have it and you can believe anything that is in the Bible, or you don't have it and then you are allowed by science not to believe it. Okay, thank you for your patience, and what I really hope is not to have confused you even more.